if you take a 10,000-foot view and you look at these system components, that this is maybe pretty normal in a lot of foundation models or ML systems. To me, this reminds me of another entire system and software that's really commonplace. To me, this looks like a database. And the way I think about this is, you have historical data and local data. Those are like tables of large amounts of data. Training to me is kind of like building an index. It's a way of making sense of the data in a way that it's like really appropriate for querying. The ML model itself is kind of like a new sophisticated query engine. And inference, like a weather forecast, is kind of like a query. And in the process of fine-tuning the model, it's kind of like you're re-indexing or re-massaging the data in the tables. And maybe updating an index could be making a forecast. And once I kind of put this connection together, I couldn't really not see the parallels between machine learning models and databases. And I think it's a really apt description to think of ML models as databases, primarily because most of the complexity of building MetNet wasn't in the creation of the model itself. It was in the assembling of the data set that spanned the entire Earth of all the different data sources and different data modalities. MetNet itself, it's like a UNet. A UNet is a type of neural network that was first created for medical image segmentation in like 2016, and it's kind of taken the world by storm. It uses a mixture of convolution and transformer-based architectures for those who care. But at the end of the day, like MetNet itself, the ML model idea wasn't relatively new. It was the thing that worked the best. What was really innovative, I think, about the system of MetNet is the assembling of a global data set to make sense of the world and to make sense of weather variables, combining Earth observation to simulated weather data.